This video is on maximum and minimum points. So a stationary point occurs when the derivative function, so f dash x, equals 0, and it creates a horizontal tangent. So you can see in that little picture at the top corner there, the horizontal tangent is like a maximum or minimum point of a curve. So we've got different types of maximum and minimums. We have a global maximum, which is the maximum value of the entire function, a local maximum, which is a turning point on a graph, a global minimum, which is a minimum value of the entire function, and a local minimum, which is a turning point as well. Sometimes your global and local maximum or minimums can be the same point. So on this graph here, if we're looking for the global and local maximum and minimums, so the global maximum is the maximum value of the entire function, which would be point D, because the largest y value is 18 on this whole function. Our local maximum would be when we're looking at a maximum turning point, which would be B. With our global minimum, our lowest possible point on this graph, which is point A. And then our local minimum is any turning points that are a happy face, because it's a minimum, and that would be point C. Okay, so that's just what global and local mean. Most of the time you will be asked to find locals, or it could just say a maximum or a minimum. Global can come into it, but it is rare. So first example, find and classify all stationary points of the function x cubed minus 3x squared minus 9x plus 5. If we're going to be doing this by hand, the first thing we need to do is find the derivative, because then we want to know where that gradient equals 0. So we find the derivative of this function, we will get 3x squared minus 6x minus 9. And then we want to find our stationary points there, we want to know when our derivative equals 0. So we'll have 0 equals 3x squared minus 6x minus 9. Put that into your calculator, so you've got a quadratic, so you can use a quadratic solver. You can use your graphing, whichever you like, and then you would find that we have stationary points when x equals -1 or at x equals 3. So at this point we don't know if they're maximum or minimums, but we know that's where the stationary points are. And from here then we can find out if they are maximum or minimums. Obviously you're going to have a calculator in your exam, so the easiest way to do that is then to graph it and look at when x equals -1 and x equals 3 and see if that is a maximum or a minimum. And if you do that, you will find that the maximum is when x equals -1 and the minimum is when x equals 3. And they're also local because they're just the turning points. And then if you found the coordinates of those, that would be -1, 10, and 3, -22. And you can do that on your calculator or you can do it by hand. That's your choice. Another way you can work out by hand if they're maximum or minimums is to do something called a sign diagram. So just quickly, you draw a little number line. We put our x values on there, so we had -1 and 3. Now we know the gradients at those points are 0. So what you do is you just pick a number before -1, put it into your gradient function to see if the gradient was positive or negative. So a number less than -1, put that into our gradient function, so our derivative. So say if I put -2 into 3x squared minus 6x minus 9 for x, got our answer for that. We don't need to know what the actual answer is, we just need to know if it's positive or negative, and you will find the answer to that would be positive. Pick a number between -1 and 3, put it into the function, see if the gradient's positive or negative. You will find it was negative. Then you can put it into, then you want a number bigger than 3. So say 4, put that into the derivative function, you would find the answer would be positive. So if we looked at that here, if it's positive, we know it's going up. If it's negative, then it's going down, and then positive, so it's going up. So you can see here, this would be a maximum, that's a minimum. So that's how you can tell if it's a maximum or a minimum by hand. Example 2, find the local and global maximum on the curve of 2x cubed minus x squared plus 1 between -1 and 1. So what I would do with something like this is I would just graph it on your calculator and restrict your domain. So make your zoom x values between -1 and 1. If you do that, you'll find that your graph looks something like this. Okay, so this would be when at -1 and that would be at 1. Now we can see here then that means our global maximum is at our end point here. That's the highest point on the graph. So you've got a couple of ways of working this out. You can just find it on your calculator, or just put 1 into your y function. So if we put 1 into here, you'll find the answer is 2. So our global maximum would be at 1, 2. And then for our local maximum, we're looking here, and you can probably see there is a little dip in the graph. So our local maximum point is somewhere around the y-intercept. Once again, on your graph, if you just search for in a range what the maximum value is on using your calculator, it will bring that up, and so that point is your maximum. And if you do that, you find that the maximum is actually at the y-intercept, is at 0, 1. To do it by hand, all we need to do is do our derivative of our function, which would be 6x squared minus 2x. Make that equal 0. If you solve this, you will get 2 solutions for x, because it is a quadratic, and so we will get when x equals 0 and also when x equals a third. And then from there, by hand, we would do our little sign diagram again. So we'd have 0 and a third on there. Pick a number before 0, so say -1. Put that into our derivative function, so the 6x squared minus 2x, see what's happening before it, and you would see that the gradient would be positive before 0. Pick a number between 0 and a third. Put that into the gradient function, you would find your answer would be negative, and pick a number bigger than a third, say 1. Put it into the function, you would find it would be positive. So from here, we know it's going up, then down, then up. So obviously 0 is the maximum, and the 1/3 would be the minimum. So obviously you do have a calculator, so depending on how the question is asked, you should just be able to do it straight on your calculator, but the steps could be broken down and it may look something like that.